Good morning, 8th grade. We are going to go ahead and finish up section 6 of chapter 6. Today we're going to be focusing on a couple of word problems that have to do with systems of inequalities. There were two leftover cutouts from our last lesson, but I did decide to scrap one of them, and I printed out a new one. You can find that on the cutouts page. I did update that. So just reprint it out and cut out the new one, and that's the one that we're actually going to use. Alright, so I have put a number 3, a letter A, and I have already glued mine in. So I'm going to go ahead and get started. It says you are planning what to do after school. You can spend at most 6 hours daily playing basketball and doing homework. You want to spend less than 2 hours playing basketball. You must spend at least 1.5 hours on homework. What is a graph showing how you can spend your time? Now, this is actually going to use 3 separate inequalities, and I'm going to show you how we come up with them. So, I'm going to kind of write these out. So this will be the total time. This will be time for basketball. And this will be homework. Okay. So we have 3 separate inequalities that we're going to be dealing with here. Let's do the total time first. So we need 2 variables. Let's say we have x represent amount of time. Whoops, I can't spell amount of time for basketball, and y will represent the amount of time for homework. Okay. Now you could do it the other way around. If you wanted to make x for homework and y for basketball, it wouldn't matter. Totally up to you. Okay, so I'm going to focus right here on this sentence because this is going to tell me how I'm going to set up my first inequality, and that's for the total amount of time. So it says you can spend at most 6 hours daily playing basketball and doing homework. So at most, that means that 6 hours is the greatest amount of time that we're going to be able to spend. So whatever time we do, it's got to be equal to or less than 6 hours. So that means a total combined time of both basketball and homework. So combined time of basketball and homework. Okay, so whatever I do for basketball and whatever I do for homework, together they've got to be less than 6 hours. So that makes sense. X plus y less than or equal to 6. Now these two are going to be a little bit different because, well, you'll see in a second. All right. So you want to spend less than 2 hours playing basketball. So less than 2 hours playing basketball. So we said that x is going to represent the amount of time that we're doing for basketball. So x less than 2 hours. Okay? So we know on the graph this is just going to be a straight vertical line, but that's okay. Sometimes your inequalities are that simple. Alright, next one, you must spend at least 1.5 hours on homework. So at least. So whatever we do here, it's got to be at least. And I'm going to just write it as a decimal, 1.5 hours. So those are our 3 inequalities. The hardest part of this, guys, is going to be figuring out what your inequalities are going to look like. Graphing them is the easy part. So what we're going to do now, we're going to head on over to a piece of graph paper. If you don't have graph paper, it's not a big deal. But I'm going to use a piece of graph paper. I'm going to save my shading until the end. And this is 3A. Okay, I'm just going to draw. That's a pretty straight line right there. And draw. Alright, that's good enough. Okay, so we have x plus y was less than or equal to 6, x had to be, was it less than 2? Yes, less than 2. And y had to be greater than or equal to 1.5. Alright, so I'm going to pause and graph each of these. Pay attention to, oh wait, time out. I forgot to do something. We're not ready to graph this one yet, are we? No, we have to put it in y equals mx plus b. So, I need to move x. I need to move x. Y is less than or equal to negative x plus x. There we go. Let me fix that on my paper, and then I can graph. There we go. Much better. Okay, so now I'm going to pause, and now I'm going to graph. Pay attention to your signs, and if you have an equal to bar, or if you don't, because that is going to determine what your graph is going to look like. So I'll pause, and I'll be right back. Okay, so I have graphed each of my 3 lines here. This one is y is less than or equal to negative x plus 6. This one was x is less than 2, and this one is y greater than or equal to 1.5. So you can kind of see where they all overlap. It's this very dark shaded region here. So the last part of this asked, what does the graph show? Oh, we just had to graph it. Okay, so we did graph it. So if I wanted to see like how much time I could spend, you know, doing homework and doing basketball, remember x was basketball and y represented our time for homework. So if I picked a point in here, if I picked, let's say, this one, that would be 1 hour doing basketball and 3 hours doing homework. So yep, that would fit, because if I did my original graph, x plus y less than or equal to 6, 1 and 3, yep, that's still less than or equal to 6. I'm spending less than an hour on basketball and more than 1.5 hours on homework. So yeah, that one would work. Anything in this shaded region would work. And you could even go into portions of hours, you know, 1 hour, 15 minutes, something like that, just as long as it's in that little shaded region there. Alright, let's go ahead and try our next one. I'm going to actually hop over to a new page. Okay. And I'm going to put a B. Come on, page. Sit flat. Oh, it's stuck. Hang on, guys. I'll be right back. Alright, sorry about that. My pages were sticking together from, I guess, some extra glue. While I was paused, I went ahead and glued in this next one right here. This one is only going to have, I believe, 2 inequalities. So this one's a little bit different. You kind of have to determine, you know, how much information they're giving you, how many inequalities am I going to have, what are my variables going to be, and then that'll determine, you know, how you graph it. So let's go ahead and get started here. It says you can work a total of no more than 10 hours each week at your 2 jobs. House cleaning pays $5 per hour. That is very bad pay. And your sales job pays $8 per hour. I see why they need 2 jobs. You need to earn at least $56 each week to pay your bills. Write a system of inequalities that shows the various numbers of hours you can work at each job. Okay. Got a lot of information here. Let's start with our variables. Let's say that x is going to represent the number of hours at your cleaning job, number of hours cleaning, and y will represent your number of hours in sales. Okay, let's begin there. Okay, so we're going to have 2 inequalities here. One is going to deal with strictly your number of hours. The other one is going to deal with your amount of pay. So let's do number of hours first. It says you can work a total of no more than 10 hours each week. Well, maybe you guys would actually like to see what I underlined. There we go. No more than 10 hours each week. So that means 10 is the greatest amount. So 10 is your greatest amount. Whatever you work, it's got to be equal to or less than 10. So total of no more than 10 hours, that means however many I do cleaning and however many I do in my sales job combined have to be less than 10 hours. So the hours combined must be less than 10. So that deals with strictly the number of hours for my job. Now let's go over to the inequality that deals with the amount of pay. It says house cleaning's $5 an hour, sales job's $8 an hour, and I need to earn at least $56 each week to pay my bills. So at least. So $56 needs to be the smallest amount that I'm going to get. So whatever I earn, if it's greater than or equal to 56, I'm happy. Alright, so my cleaning job pays $5 per hour. So however many hours I work, it's $5 times the number of hours. So 5 times the number of hours. Okay? And my sales job is $8 an hour. So 8 times however many hours I work. And together, I need to get at least 56 bucks. Alright, I have my two inequalities, but I'm not ready to graph yet because they need to be in y equals mx plus b before I can go ahead and graph. So, I'm going to pause, and I'm going to turn each of these into y equals mx plus b. I would like you to pause and do the same, and at the end we'll check and see if our answers match. Okay, I am back. So the first one was relatively easy. All we had to do was move x over to the other side of the equation. We got y is less than or equal to negative x plus 10. The other one was a little uglier because I don't like that 5/8 fraction, but it is what it is. We had to move 5x to the other side of the equation. Then we had to divide by 8 on both sides. And we got y is greater than or equal to negative 5/8 x plus 7. So now we're ready to go ahead and graph. So I'm going to head back over to my graph paper. And I'm just going to do this one right underneath. Let me move this down a little bit. There we go. And we'll call this 3b. Okay. And I'm going to draw y-axis. Look at that straight line. It's beautiful. X. Ooh, that one's not straight. Not beautiful. X-axis. Okay. Alright, so the two equations that I'm graphing are y is less than or equal to negative x plus 10. Yes, 10. And y is greater than or equal to negative 5/8 x plus 7. Okay, so I'm going to pause. I'm going to graph both of these, and then I will be back. Alright guys, I am back. I actually had to redraw my graph because I, one, didn't make it big enough, as per usual, and I also mixed up my y-intercepts with the other equation, so I had to fix it. Anyway, I did graph them, and this is what I got. The window of opportunity we have here to make both of these work is kind of slim, if you see. So this one here is my y is less than or equal to negative x plus 10, and the other line here is my y is greater than or equal to negative 5/8 x plus 7. So we only have this very slim amount in here where it's going to work, but anything in there will satisfy our requirements that we get, you know, we don't work any more than 10 hours a week, but we still make, you know, at least our $56. Where they intersect will be a solution because they both have the equal to bar. So that will be a solution, and anything in this overlap region will also be a solution. And I don't think this would be here because that's only for this one because it's greater than. So yeah, this and anything in this overlap region So for example, if I picked this point, okay, so this is X was my number of hours cleaning, and Y was my number of hours at my sales job. So this would be 1, 2, 3, 4, 5, 6, 7. So at 2, 7, that means I'm doing 2 hours cleaning, 7 hours of sales. I'm still working less than the 10 hours that I wanted to, and that would mean, how much would I be making? 10 plus 56. So I'd be making $66. Yeah, so that would work. Satisfies both requirements. All right, so I'm going to have you pause here. You're going to head on over to IXL and do some practice with the word problems there. The hardest part is going to be setting up your inequalities. Okay, if you can do that, graphing it should be a breeze. But really take your time, look at the wording, what symbol am I trying to use here, what are my variables, and, kind of go from there.